This document also provides a lot of information about multiple spanning tree, or 802.1s. You're not expected to know all the detail in this document, but it provides a nice reference if you're interested. I'll cover some of the basics now, and then you can read the document if you're interested in more information. Multiple spanning tree is the new industry standard inspired by Cisco's proprietary multiple instance spanning tree protocol. Cisco developed multiple instance spanning tree protocol to solve some of the issues that you have with PVST. So as the number of VLANs configured in switched networks increases, the overhead when running PVST also increases. If you configure 1,000 VLANs with PVST and rapid PVST, you end up having 1,000 spanning tree instances. But with multiple spanning tree and the proprietary multiple instance spanning tree that existed before multiple spanning tree, you can map a number of VLANs to the same spanning tree instance. It's fairly simple to do this, but the idea is if you had 1,000 VLANs, you would allocate 500 to one instance and the other 500 to another instance, which means you only have 2 spanning tree instances rather than 1,000 spanning tree instances. So multiple spanning tree standardizes the concept of multiple spanning trees and incorporates the convergence of a rapid spanning tree. Multiple spanning tree allows you to group VLANs to a shared spanning tree instance. It also defines a protocol for interconnecting multiple spanning tree regions, how to interoperate with existing 802.1d and 802.1q spanning tree implementations, and provide some best practices. So have a look at this document if you're interested in a lot of detail. But here's a quick comparison. Imagine you had 1,000 VLANs on switch A, which is connected to both switch D1 and D2. So in this topology, switch A has 1,000 VLANs. D1 is going to be the spanning tree root for some VLANs, and D2 is going to be the spanning tree root for other VLANs. So switch D1 is configured to be the root for VLANs 501 to 1000. D2 is the root for VLANs 1 to 500. The interface from switch A to switch D1 blocks VLANs 1 to 500, and from switch A to D2 blocks VLANs 501 to 1000. So once again, root for these VLANs, traffic will be forwarded out of this port for those VLANs, but blocked for VLANs 1 to 500. This switch is the root for these VLANs. This port will forward traffic out of it for VLANs 1 to 500, but will block VLANs 500 and 1 to 1000. It's very inefficient to maintain 1,000 spanning tree instances in this network. We have 500 spanning tree instances with D1 as the root, and we have 500 with D2 as the root. But logically, we actually only require 2 instances. D1 should be the root for instance 1 that contains these VLANs, and D2 should be the root for instance 2 that contains these VLANs. You associate these VLANs to instance 1 and make D1 the root. You associate these VLANs to instance 2 and make D2 the root. That means you have to maintain 2 instances rather than 1,000 instances. So that kind of detail is explained here. I'll go through it quickly. In a Cisco PVST environment, you need 1 spanning tree instance for every VLAN, which means you have 1,000 instances for the 2 different final logical topologies, with D1 as the root for one topology and D2 the root for the other topology. This wastes a lot of CPU cycles for all the switches in the network, in addition to the bandwidth used by sending BPDUs. 1,000 BPDUs are going to be sent out of every port every 2 seconds because PVST sends a BPDU for every VLAN because we have an individual instance mapped to every VLAN. So the idea with multiple spanning tree is that you get the best of PVST and traditional spanning tree. You map several VLANs to specific instances. So in our topology, once again, you'd make switch 1 the root for instance 1, switch to the root for instance 2. This port would forward for instance 1 but block for instance 2. This port would forward for instance 2 but block for instance 1. Only 2 spanning trees are maintained rather than 1,000. So you still get load balancing because half of the VLANs follow a separate instance, and you save on the CPU because you only have 2 instances of spanning tree. So from a technical point of view, multiple spanning tree is the best protocol to use in this example, but multiple spanning tree is more complex to configure than PVST, and interaction with legacy switches can be challenging at times. So you would only want to use multiple spanning tree if you have many VLANs. So in this example, we have 1,000, so it makes sense to use multiple spanning tree. If you only had 10 or 20 VLANs in your network, you could continue using PVST or Rapid PVST. The document continues with a lot of detail on how to configure multiple spanning tree regions, but that is out of the scope of the CCNA. So have a look at this document if you're interested, or wait till you get to your CCNP certification.